India is largely an agrarian economy where even today more than 50% of its population is dependent on agriculture. One of the factors responsible for it being an agrarian economy is that the country is blessed with monsoon rainfall that provides the water required for agriculture. However, not all regions receive equal or adequate rainfall. This is the major reason why irrigation becomes a necessity in many areas of the country. Many parts of the country still use traditional methods of irrigation. However, modern irrigation methods are also adopted today. Let's look at these methods in detail. Traditional methods of irrigation include well irrigation, canal irrigation, and tank irrigation. Click each image to learn more about each type of irrigation. In our country, wells have been used as a source of water since ancient times, and even today, around 40% of the area is irrigated with the help of wells. There are three types of wells used for irrigation: unlined wells, lined wells, tube wells. Unlined wells, also called kacha wells, are not lined with rocks or bricks. These are dug by farmers near their fields. They are dug in areas that have a high water table. These are easy and convenient to dig, but their drawback is they dry up during summer months. Lined wells, also called as pakka wells, are lined with bricks and rocks. An important characteristic is that they are perennial in nature and are dug in areas that have a high water table. These are more expensive to dig than the unlined wells. A tube well is a very deep bore that is dug in the ground using drilling machines. Water is pumped out into a reservoir using an electrical pump. From here, the water is taken to the fields. Tube wells are more reliable since these do not dry up during summer months. In this form of irrigation, water from the rivers is channeled into canals. It is an important source of irrigation, especially in northern India, where many perennial rivers flow. Canal irrigation is of two types: perennial canals and inundation canals. Perennial canals flow throughout the year, since these are drawn from perennial rivers or artificial lakes that have been built by the construction of dams. These are useful for irrigating large areas. Inundation canals are not drawn from rivers using weirs or dams. These only flow when the river floods. At these times, the excess water flows into the canals. These canals, as their name suggests, are more useful for controlling floods, but not for irrigation. Tanks are an important source of irrigation, especially in the Deccan Plateau region of India. Nearly 12% of the irrigated land of the country uses this form of irrigation. Tanks are built constructing walls across valleys or depressions where rainwater is collected. The base rock of the tank has to be non-porous to prevent seepage of water. Tanks help to raise the water table of an area. They are cheaper to build. Though traditional irrigation methods are still heavily used in India, modern methods of cultivation are fast replacing some of them. These are more reliable as they provide water through the year and help to irrigate larger areas. Click each image to see how these modern methods of irrigation work. In furrow irrigation, In furrow irrigation, narrow channels are dug between rows of crops. These channels need to be of equal dimensions so that water is evenly distributed in the field. Water, when poured into the field, reaches the crops through these channels. However, here the amount of water used is relatively high. In a sprinkler system, a water pipe takes water from a water source to the field where a spray gun releases the water that is sprinkled over the crops. This system is used in dry areas and where land is uneven. It is an efficient water-saving system as the flow of the water can be easily controlled. It also helps to reduce the total water consumption. A drip system carries water through a network that consists of main pipelines and connecting pipelines. The drip system saves water as it supplies water right to the roots of the plant instead of the entire soil surface. It is useful in places that experience water scarcity. Dams are built across rivers, streams, or estuaries. Different factors determine the size and shape of the dam. Therefore, there are different types of dams. For example, a gravity dam is built to resist the horizontal force of the water with its weight. It is therefore made with a large amount of concrete. An arch dam is a curved dam and uses the arch shape for its strength. It is thinner and therefore requires less material than any other type of dam. Building dams has a number of benefits. One important benefit is it works as a source of water supply, especially in the dry seasons. The reservoirs of dams provide water to the farmers for agricultural purposes. Dams help in developing the inland waterways as they tend to slow down the pace of the river and make inland transportation easier. The areas near dams are a source of tourist attraction as many leisure activities such as boating and fishing develop around here. One of the most important functions of dams is to generate electricity. Dams convert the energy of falling water into electricity. Electricity produced in this way is called hydroelectricity. Let us see how electricity is generated. By building dams across a river, the free flow of water is stopped. This increases the water level on the side where water is held back. Deep below, there are gates in the walls of the dam that control the flow of water. When the gates are opened, the water rushes through a pipeline called a penstock. This pipeline or penstock leads to the turbine. The force of the flowing water falling from a height helps to move the blades of the turbine. The turbine is connected to a generator. The rotation of the turbine blades causes the rotor in the generator to rotate as well. This produces electricity. This electricity is then converted into higher voltage power by transformers. The higher voltage power is then carried through huge transmission lines to various cities and towns. The flowing water after producing electricity flows through pipes and joins the river. Thus, dams play an important role as they help in clean energy creation. One of the most important priorities of the Indian government after independence was the development of water resources. To achieve this goal, the Indian government launched several river valley projects. These projects are called multi-purpose projects as they are designed to serve multiple objectives. The primary objective of multi-purpose projects is to construct dams across rivers and supply water for agriculture through canals. Secondly, to produce hydroelectricity. Dams convert the energy of falling water into electricity. It is one of the least polluting methods of producing electricity. Thirdly, to regulate floods using the control gates effectively. Fourthly, to facilitate cheap inland water transportation across major river channels in the country. This reduces the pressure on road and rail transport. Fifthly, to develop inland fisheries in a scientific and controlled manner. And lastly, to develop areas near dams as places of tourist attraction. Several sites have well-developed resorts that facilitate leisure activities such as boating and fishing. Since independence, the Indian government has launched nearly 162 multi-purpose projects to ensure optimum use of water resources. Let us learn more about a few of them. The first multi-purpose project to be launched in free India was the Damodar Valley Project. The river Damodar rises in the Chota Nagpur plateau and flows through present-day Jharkhand and West Bengal before meeting the river Hooghly. The project was jointly undertaken by former Bihar and West Bengal. A series of dams were constructed in stages at Tilaya, Maithon, Konar, Bal Hill, Bokaro, Barmo, Durgapur and Panchet Hill. Hydroelectricity is generated at Tilaya, Maithon and Panchet. The canals are used for irrigation and cheap transportation of coal and iron ore to the industrial belts. Thus, the Damodar Valley Project is a boon to the industrial development of Jharkhand and West Bengal. The Bhakra Nangal project is one of the largest multi-purpose projects in India. The project was jointly undertaken by Punjab, Haryana and Rajasthan. In the first stage, the Bhakra Dam was built in Himachal Pradesh with a huge man-made reservoir named Gobind Sagar. In the next stage, an auxiliary dam was constructed to the south of Bhakra at Nangal in Punjab. This project provides irrigation for nearly 2.7 million hectares of land spread over Himachal Pradesh, Punjab, Haryana, Rajasthan and Delhi. It is also significant with the success of the Green Revolution technology in Punjab and Haryana. It is also the largest hydroelectricity generation project in India with 4 hydroelectric stations. The Mahanadi Valley Project or Hirakud project has one of the longest dams in the world. It is constructed across the river Mahanadi. Besides the main dam at Hirakud, dams are also built at Tikarpara and Neeraj. Through this project, irrigation and hydroelectricity is provided to Odisha, Chhattisgarh, Jharkhand and Bihar. Flooding has reduced considerably in the Mahanadi Delta. The Nagarjun Sagar project is constructed across the river Krishna near Nandikonda village in Andhra Pradesh. The main aim of this project is to provide irrigation and generate hydroelectricity. The Jaikawadi project was launched across the river Godavari near Paithan in Maharashtra. The reservoir is named Nath Sagar. Apart from irrigation, the project also has a well-designed garden, fish breeding center and bird sanctuary. Besides these, there are other major projects along the river Narmada, Beas, Tungabhadra, Kosi, Chambal, Gandak and Ramganga.
Rainwater harvesting. The collection of rainwater for future use is called rainwater harvesting. Normally, rainwater that falls to earth will seep into the ground where it becomes groundwater. Increases in construction and road work have decreased the available ground that would allow rainwater to soak in and recharge the groundwater. In addition, the excess drawing of groundwater for domestic purposes will delete it to dangerously low levels. Rainwater harvesting is one of the methods used to conserve water. In some areas of India, check dams or earthen embankments around the fields are built to collect rainwater and allow it to percolate into the ground as a way of recharging groundwater. However, the most widely used modern method is the rooftop or terrace rainwater harvesting. With this method, rainwater that collects on the rooftop is directed through pipes into large underground storage tanks. Once filtered, this stored water can be used. A similar method is through the use of percolation pits. The rooftop water is directed into percolation pits dug into the ground. The pits are filled with a bottom layer of brick pieces, a middle layer of gravel, and a top layer of coarse sand. The layers of sand, gravel, and brick filter the rainwater before it moves through outlet pipes into the ground. Rainwater harvesting through percolation pits also recharges the groundwater. Summary: the collection of rainwater for future use is called rainwater harvesting. Rooftop or terrace rainwater harvesting is used to store water for domestic use or to recharge groundwater.
If you live in an area that is prone to water scarcity, you would know the value of the water that is being wasted here. Imagine then how large the scale of water wastage is when rain falls and it is allowed to run off. Even though our ancestors realized this and devised various water storage mechanisms such as step wells and storage wells, water wastage and scarcity has remained a problem not only in India but the world over. Wastage of rainwater can be checked through rainwater harvesting. Rainwater harvesting is the collection and storage of rainwater either for using it directly or for recharging groundwater. Let's see how this mechanism works. In this system, when rain falls, the water is received on a surface such as the terrace shown here. This surface is called the catchment. The rainwater is allowed to flow from the catchment through pipelines to a storage reservoir or recharge facility. These pipelines are called conduits. As the water collected in the catchment may contain debris, a mesh filter is usually provided at the mouth of the conduit. This mesh filters the water flowing from the catchment to the storage facility. The conduit carries the rainwater to water tanks where it can be stored for immediate use. Apart from storing, the collected water can be directed into groundwater aquifers for later use. Here, the water is allowed to percolate into the soil, thus raising the water table. Different kinds of recharge mechanisms can be used. For instance, dug wells act as efficient rechargers of aquifers. Similarly, bore wells may also be used to recharge the groundwater aquifer. Recharge trenches can also be dug up to guide the rainwater to a recharge pit. These trenches have regular openings to collect the surface runoff of water and direct it to a recharge pit. Through this pit, water percolates into the aquifer and recharges it. In this way, through rainwater harvesting, wastage of rainwater can be prevented by harnessing the water in the months that experience heavy rainfall. The water thus conserved can be made available for later use, especially in drier months.